Physics 251 Video Explainer Problem 57. A rubber ball bounces. We'd like to understand how the ball bounces. Part A. A rubber ball has been dropped and is bouncing off the floor. Draw a motion diagram of the ball during the brief time interval that it is in contact with the floor. Show 4 or 5 frames as the ball compresses, then another 4 or 5 frames as it expands. What is the direction of acceleration during each of these parts of motion? Part B. Draw a picture of the ball in contact with the floor and identify all forces acting on the ball. Part C. Draw a free body diagram of the ball during its contact with the ground. Is there a net force acting on the ball? If so, in which direction? And Part D. Write a paragraph in which you describe what you learned from parts A to C and in which you answer the question, how does a ball bounce? So, in Part A, we are needing to draw a motion diagram for the time in which the ball is in contact with the floor. And so there will be 2 different parts. There will be the first part in which the ball is compressing, and then the second part in which the ball is expanding. So when the ball is dropped, it is accelerating downward. It has a downward direction of acceleration. The velocity will be increasing, and then when the ball hits the ground, the velocity decreases and the acceleration switches directions, so it will have an upward direction. When the ball is expanding, it will maintain its acceleration in the upward direction, and then the velocity will also switch direction. So for Part A, the direction of acceleration during both compression and expansion is upward. In Part B, we are drawing a picture of the ball on the floor and identifying the forces. And so while the ball is in contact with the floor, there are only 2 forces acting on it. The first force is gravity. Seeing as the ball has weight, it will always be affected by gravity. And then because the ball is in contact with the ground, it also experiences normal force. And so this is our diagram for Part B with our gravitational and normal forces labeled and identified. And then in Part C, we are drawing a free body diagram of the ball and identifying any net force as well as the direction of the net force. And so here is our diagram in which we have both our gravitational force and our normal force, and there is a net force, and that net force is in the upward direction. And then for Part D, we are explaining what we learned in parts A through C, as well as answering how a ball bounces. And so when the rubber ball is dropped, it accelerates downward until it makes contact with the ground, at which point it compresses before expanding. When the ball is compressing, the acceleration changes directions and has both normal and gravitational force. So there we have talked about both parts A and B. We've identified the force and talked about the acceleration direction. And then continuing on, the ball maintains direction of acceleration and acting forces during expansion. While the ball is in contact with the ground, it has a net force in the upward direction. So there we have included part C. And after leaving the ground, the ball will no longer experience normal force, and gravity will be the only force remaining. And with that, we have answered all parts of the problem.